Texas earthquakes are still going on. 4.4 magnitude today and 3.3 about 20 minutes earlier in the area of recent quake swarm in the area between New Mexico, and Texas. And something very strange is going on there. Let's take a look at the map. And here we are, 4.4 at a depth of about 5 miles. And this one here was about 20 minutes earlier, 3.3. And that's about what? I would say 100 miles east. And this is our earthquake area. 11 people reported feeling it, even though there's not many people living there. And this is our shake map of the area. Pulling out a little bit, we can see right in the central right there. These are, of course, fracture zones right there, fault lines. And going to the topography. New Mexico, Texas. This is the area of our earthquake swarm. Now, this is Lubbock airfield right there, up there. Where was it? Okay, you saw that right there. And I was looking at the volcanic areas of Texas, and we do have a volcano. Pilot Knob rising out of lowlands west of Cottonmouth Creek. It's right there, though. It's nowhere near where we had our earthquakes around here. This is it right there. Cretaceous period volcanic complex scattered around central Texas from Waco to Austin, San Antonio del Rio. The volcanic complex consists of four small rounded hills, including Pilot Knob proper, forming the volcano's core area. An area of 2 miles, the hills are composed of trap rock, fine granite mafic right here, material silicate mineral igneous rock. The complex rises above the circular lowlands. And the history of the volcano, Cretaceous time, central Texas was part of a vast marine shelf. And explosive eruptions continue at Pilot Knob as new magma encountered more water in the volcanic ash. Right there. Gradually the ash cone, look at that, was built up over the explosion crater. And Pine Knob ash cone eventually built an unstable slope on the sea bottom. But dating the volcanic activity, the first approach was through the stratigraphy rocks around Pilot Knob, and the second about the isotopic age data of igneous rocks. The magma source. The igneous rocks of Pilot Knob volcano have not as yet undergone rigorous petrological study, but we do know this. Okay, we've seen this many other times. I've explained this to you. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. This thing here on the Great Lakes, that area there, there's a magma plume there from about 1 billion years ago. And that's one of the oldest magma plumes on the Earth. They don't know where that's coming from, but it's there. And it has a horseshoe shape like this. And it goes to the east like this around this area of the New Madrid seismic zone, the rift zone. And the other part goes down like this through Kansas, Arkansas, into Texas, and then goes west. Okay, right there. The Great Plains area, that's a spreading there. The Superior area was much closer to Yellowstone at one point, and that's spreading because there's magma underneath. So that plume there does go under Texas as well. They're still finding this out. This magma underneath the United States. Most of us think that it's only here, San Andreas and Walker Lane Fault System, the high threat volcanoes, and the other part goes through Utah and into Yellowstone, then makes a west turn into Idaho. So this is our area here of our quake swarms, and this is 4.4 as we can see, and we know that that is usually felt 10 times more than on the West Coast. Most of North America east of the Rockies has infrequent earthquakes. Earthquakes are more numerous, for example, in New Madrid seismic zone, centered on southeast Missouri, Charlevoix-Kamouraska seismic zone east of eastern Quebec, New England, New York, Philadelphia, Wilmington. But most of the enormous regions from Rockies to the Atlantic can go years without an earthquake large enough to be felt. Now, these things here, I don't know if they're from fracking or whatever, but, you know, the fracking earthquakes used to be, the man-made earthquakes were like 1.8, 2, 2.5, 3. Now they're going much bigger. 4.4 is not small. Okay, because if, you know, your house, if there's not that many houses out there, let's go to the population. You can see topography. Let's go to the population. Okay, there's not that many there. Not much of a population there. Let's go to the aerial again. Okay. So, but still, there were 11 people who reported it. Now, most earthquakes in North America east of the Rockies occur as faulting within the bedrock, usually miles deep. Few earthquakes east of the Rockies have been definitely linked to mapped geological faults, in contrast to the situation at plate boundaries such as California's San Andreas fault system, where scientists can commonly use geologic evidence to identify a fault that has produced a large earthquake and that's likely to produce large future earthquakes. Scientists who study Eastern and Central North American earthquakes often work from the hypothesis that modern earthquakes occur as a result of slip on pre-existing faults that were formed in earlier geographic areas. The bedrock of Eastern North America is laced with faults that were active in earlier geologic eras, and few of these faults are known to have been active in the current geologic era. The most areas east of Rockies in likelihood of future damaging earthquakes is currently estimated from the frequencies and sizes of instrumental recorded earthquakes or earthquakes documented in historical records. Now, the induced seismicity, the man-made earthquakes. As the case elsewhere in the world, there's evidence that some Central and Eastern North American earthquakes have been triggered or caused by human activity that have altered the stress conditions in Earth's crust sufficiently to induce faulting. Activities that have induced felt earthquakes in some geologic environments have included impoundment of water behind dams, injecting of fluid into the Earth's crust, in other words, hydrofracking, extraction of fluid or gas, and removal of rock in mining or quarrying operations. In much of Eastern and Central North America, the number of earthquakes suspected of having been induced is much smaller than the number of natural earthquakes, but in some regions such as south central states of the U.S., a significant majority of recent earthquakes are thought by many seismologists to have been human-induced. Even within areas with many human-induced earthquakes, though, the activity that seems to induce seismicity at one location may be taking place at many other locations without inducing felt earthquakes. In addition, regions with frequent induced earthquakes may also be subject to damaging earthquakes that would have occurred independently of human activity. Making a strong scientific case for a causative link between a particular human activity and a particular sequence of earthquakes typically involves special studies devoted specifically to the question. Now, I just want to go into, to see as much as we can in there. Let's go to the aerial and take out some of these, take out some of these things so we can see better. We'll just keep the epicenter there. Okay. Take this out. Okay. And let's go in there to see what we can as far as we can. Yeah, there seems to be fracking there. There you go. All these seem to be fracking. It's a fracking area. Okay. All these grids are most likely fracking areas. So this is probably what's causing all this. Anyway, all of you there, please be very careful. Please leave your comments and thank you for your support.